for my listeners, when you look at star evolution, I think a big concept in here is to understand that it's not a straightforward thing. It isn't the star just cools, shrinks, and dies and becomes a planet. It's not that straightforward. It's a bit more complex. And we have these complex examples inside of, well, nature. Just go outside. Sometimes it rains. That's the feedback loop. And that's what I'm going to talk about here. Now, for those that understand that we have different phases of matter, you have solids, you have liquids, you have gases, and you have plasma. You have to understand that they go through phase transitions. You have plasma recombining into gas, releasing heat, and then gas ionizing, absorbing heat, becoming plasma again. Liquid vaporizes into gas, and gas condenses into liquid. Solids melt into liquids, liquids freeze into solids, and gas deposits as solids, and solids sublimate into gas. That's what dry ice sublimation, if you want an example for that. But to look at a star and that it shines really brightly, it isn't that it's just releasing heat as the plasma recombines into gas, because yes, that's exactly what it's doing. But the gas also becomes reionized again and becomes plasma, and that circling loop takes hold. It's a feedback loop. And that feedback loop is provided by the gravitational potential energy, but more on that later. To understand that there's feedback loops between matter is to understand that the more energetic a star is will determine how or where the feedback loop is taking place given what material it's comprised of. For instance, you have rain, which is, water. The feedback loop in this case would be, you start out with, we'll start with liquid for this example. And something heats it up, which is the sun, and then the liquid vaporizes, so it becomes gas, right? Gas. And then it rises up into the atmosphere, okay? And it then condenses rapidly and undergoes gas deposition, meaning the gas cools rapidly and becomes solid material, becomes crystalline, crystalline structure. That's what the clouds are made of. They're small little, they're not exactly water, they're just like ice crystals that have condensed really, really fast because they gave up their energy. And then what happens is, you get enough of that in the clouds, it becomes more and more and more energetic, or it gains energy, I should say. Eventually, it will want to release all that energy and, well, become a liquid again, start raining. I don't know if I said that right, but you have this feedback loop taking place just with water. Like the most familiar molecule that we have on our star is water. But to think, what if you had feedback loops with methane or butane or, I don't know, hydrogen gas or nitrogen gas? You have phases of matter that this material goes through, and a lot of them are different energies. A lot of them are different compositions. They have different weights. Like hydrogen gas is really light, so if you have a phase transition with hydrogen gas, it would probably occur only at very high energies and very high atmospheric conditions. or very low pressure, I should say. Because, you know, water, obviously, if you get it too high, it boils away, it automatically vaporizes because it needs a certain amount of pressure to stay liquid. But if you have these different types of molecules undergoing different phases and phase transitions through this entire loop in the interior of the star, it can get incredibly complex. Like, holy cow. And the more I think about it, the more I realize it is literally so complex that astronomers and astrophysicists, they don't even want to deal with it. It's too complicated for them. The amount of theoretical models that would have to go into figuring stuff like that out would be mind-alteringly difficult. But that's why I'm drawing up this theory as well. Because not only do we not have to just purely base it on theory alone and computer models, we can literally look at an ancient star, the Earth. The Earth is one. We can literally look inside the crust and see that we have oil down there, which would probably be methane. It's been polymerized, meaning it formed long chains of hydrocarbons as it was cooling, and has gotten trapped by all the rocks, or things like basalt, the molecules inside the basalt rocks in the bottom of the ocean. We can tell how those phases of matter came to be based off of their location. Or even granite, the fact that it's like really high on the surface, relatively speaking to other elements. And, you know, what materials those are made out of, silicon, oxygen, you know. But basically what I wanted to go over is that when you have the star cooling, shrinking, and dying, the energy levels of the matter diminish considerably. And different kinds of matter show up as it evolves, and the material forms bonds, chemical bonds with itself. And depending on how complex those chemical bonds formed are, will determine, you know, what phases of matter they're more accustomed to. Because some matter liquefies at higher temperatures than others. Some matter becomes gases at lower temperatures. And those kinds of phases exist in very high pressure regions inside of that star as it's evolving. Which is why I want to also talk about supercritical matter and effusion for another talk, because I think that's really important. I should be able to explain why a lot of rocks and minerals have water in them, because of supercritical water, obviously, but just so people really get it, there are feedback loops that can sustain reactions repeatedly. It isn't a reaction, it rains once, and then the rain just stops. And it never rains ever again, because the matter just doesn't disappear. It goes back to being gas again, which then condenses back into solid crystals, and then it starts raining. And it repeats those loops over and over and over and over again, depending on the situations and depending on the conditions of the environment. And that's exactly what happens to stars. The conditions of the environment determine what kind of phase transitions can happen. Hopefully I didn't confuse people with this, but it's pretty complicated.